So how do we generate the graphs of periodic functions? And how can we shift the graphs of a periodic function? So we're going to talk a little bit here about the unit circle first, and then graphing sine, cosine, and shifting graphs of sine and cosine. So first of all, what if we're just given a problem here where we're given an angle measure in radians, and we're charged with finding the coordinates of the given angle on the unit circle. First step is always to determine where is that angle in the unit circle. So each of these here present us with a little bit different issue. The first one here is on the unit circle, 3 pi over 4. So that's a memorization problem. Where is 3 pi over 4? It is in the second quadrant, okay, right here. What is the coordinates of that angle? And x will be negative, y will be positive, so we're looking at negative root 2 over 2, comma, root 2 over 2. That's a memorization thing. Okay, remember that those coordinates represent the cosine and sine value at that particular angle, which is 3 pi over 4. The second problem, negative 5 pi over 6, is a little different. Now we have a negative involved. Okay, so step 1 is still to locate where is 5 pi over 6. That's a memorization thing. 5 pi over 6 is here. And then if we're taking the negative of that, that means we're flipping it over the x-axis to here, which would be 7 pi over 6. Okay, so what are the coordinates then at 7 pi over 6? Cosine sine values would be negative root 3 over 2, comma, negative 1/2. Third quadrant, both are negative. Again, the other way to look at that is to go start at 0 and go backwards around the circle, 5 pi over 6. The last one that we have here, 13 pi over 4, that is obviously bigger than, all right, that's greater than 2 pi. So anytime we have something greater than 2 pi, we're going to take the numerator divided by the denominator, take our, back to long division here. So 4 goes into 13 3 times. 4 times 3 is 12. The remainder is 1. Okay, now all these numbers here are important. Okay, the 3 is important because that tells us how many pi's around the circle we go. So if that's 0, and that's pi, that's 2 pi, and then that's 3 pi. So if we're at 3 pi, and we're going 1/4 farther, that will be 1/4 farther, which is 5 pi over 4. Okay, so the coordinate we're looking for is the coordinate at 5 pi over 4, third quadrant. So we're negative, negative, negative root 2 over 2, comma, negative root 2 over 2. The 3 answers you can give here are always the same. It's always negative root 3 over 2, root 3 over 2, 1/2, negative 1/2, root 2 over 2, negative root 2 over 2. You just got to know which quadrant you're in and be able to determine that using the given radian measures, all right, provided in the problem. So the better you know your unit circle, the easier this becomes. All right, next is the ability to actually use that knowledge to determine what is the cosine, sine, tangent of those particular angles. And they're given in radians. So if you're going to do this on your calculator, you can. You just got to make sure your calculator is set to radians. Your calculator will give you a decimal answer. A lot of times we're seeking a fractional answer, so the calculator isn't always the best way, but it would be a great way to check yourself. So cosine of 5 pi over 6. So first you ask yourself, where is 5 pi over 6? And you have it memorized. It's right here. Okay, the cosine value there would be the x value at that coordinate, and that would be negative root 3 over 2. Okay. Sine of negative 4 pi over 3. So again, we got to remember what negatives mean. We can either go to 4 pi over 3. So if we go to 4 pi over 3, we will come all the way around to here. Okay, that's 4 pi over 3. And then we flip that over the x-axis. And we would end up at 2 pi over 3. So what is the sine at 2 pi over 3? It is root 2. Oops, no it's not. It is root 3 over 2. And last, we had the tangent of pi over 6. So pi over 6 is first quadrant. That should be one that we all know. Tangent, remember, is y over x. So tangent of pi over 6 is going to equal 1/2 divided by root 3 over 2. Now, anytime that we get something like this where we have fractions inside of fractions. Again, we never want to divide by a fraction. We always want to multiply by its reciprocal. So in that particular case, the 2's cancel each other out, and we're left with 1 over root 3. Now, that's not the most acceptable answer. What we will have to do there is rationalize this denominator by multiplying by root 3 over root 3. Okay, so what that ends up giving us then is root 3 over 3 for the tangent of pi over 6. Okay, now moving on, graphing sine and cosine using the 5-point graphing method. First we'll do sine of x here, and that'll be in blue. And what you need to understand there, well, first of all, let's label our x-axis. Typically 6 blocks is pi, helps us out pretty good. And 2 pi. Remember the 5-point graphing method here for sine is going to be x-intercept, max, x-intercept, min, x-intercept. Okay. Now those maxes and mins, as if it's just a normal sine graph, are 1 above and below. So at pi over 2, we'd be 1 above. Pi, we'd be x-intercept. 3 pi over 2, we'd be 1 below. 2 pi, we'd be x-intercept. So our sine curve is going to look like that. Okay. Now it's not shifted or anything. Cosine, so y equals cosine of x. All right, same points, just different order.
Back when you stand serving on the academic integrity committee, that meeting will begin shortly.
Okay, we have max, x-intercept, min, x-intercept, max. All right, so cosine begins 1 above at a maximum. Okay, and then at pi over 2, it's at 0. Pi, it's a minimum. 3 pi over 2 back to 0. And 2 pi, it's back up to a max. Now, where am I getting these points? These all come from your unit circle, folks. So you look at your unit circle, you go to pi over 2, you look at the x-coordinate, it's 0. Cosine is x. Okay, you go to pi, you look at the x-coordinate, it's negative 1. Negative 1. All right, so it's all referencing the unit circle, and we're talking about 0, pi over 2, pi, 3 pi over 2, and 2 pi are our 5 points. Okay? The numbers we're always thinking of are 1 and 0. All right, maxes, mins, x-intercepts. Now, when we stretch those, that's a little different, and that's what we get into now. So here we go. This is a good one. We got negative 4, so we got amplitude of negative 4. Okay. Phase shifts we didn't talk about yet. That's going to be 1 for now, frequency. H is going to be 5 pi over 6 to the left. Okay. And K is going to be up 1. All right. The period equals 2 pi. So again, label your x-axis. Okay, and what we're going to do here, typically what I always encourage students to do is create your new x-axis using the vertical shift first. That way you can see what your graph is supposed to revolve around or cycle around. I'm going to use a dotted line for that. Okay, so that's my new x-axis. And then I want to determine how many blocks is pi over 6, 5 pi over 6. Okay. Well, if pi is 6 blocks, okay, then 5 pi over 6 would be 5 blocks. So 5 blocks. Okay? So normally sine would begin at 0, 0. In this case, it doesn't. It begins here on our new x-axis, but here it's 5 blocks to the left. Okay, so it begins over here. Normally it would end at 2 pi, but it doesn't. It ends 5 blocks to the left. Okay? The reason I'm doing the intercepts first is because they don't change. The stretch doesn't affect them. All right? Normally the halfway point or the other x-intercept would be at pi. In this case, it's 5 to the left. Okay? Now it's negative sign, so that means it's going to go min first and then max. That min's going to appear halfway between these 2 points. Okay? And it's going to be 4 below. Okay? The max will appear halfway between these 2 points, 4 above. And there's my curve. All right, you only need to have 1 full cycle for full credit. Obviously, you could graph more than 1 cycle if you desire to. Last, we have write the equation and sketch the graph of a cosine curve with an amplitude of 3, a horizontal shift of left pi over 2, so x plus pi over 2, okay, and a vertical shift of down 2, minus 2. All right, so down 2 is where I start. That's my horizontal shift, so that's my new x-axis. And then I want to determine how many blocks is pi over 2. So if pi is 6 blocks, that means pi over 2 is 3 blocks. And it's to the left. Normally cosine will begin at a max, okay? So here we are, we begin at a max of 1, but we're to the left 3 blocks, 1, 2, 3. And we're timesing that by 3, so it's actually 3 above. Okay? Normally it would end at 2 pi, 1 above it, but in this case it's 3 blocks to the left and 3 stretched. Okay? So if those 2 points are maxes, halfway in between would be the min. Normally that would fall at pi. In this case it's 3 to the left and then stretched 3. Okay? The only ones that don't get stretched are the 0 values. So halfway between these 2 points is my first x-intercept. Halfway between these 2 points is my second x-intercept. And that gives me 1 full cycle of cosine. Okay? The other thing I want you to notice is that exact same cosine curve could be written as a negative sine curve. All right, it would look like negative 3 sine of x minus 2. Just food for thought. And that's it for now, and see you tomorrow.